Hey there, everybody. This is Mr. Sheeline. If you're joining me here, you are basically just here to get the answers or see how it is I got the answers for all the check your understandings and the little set of notes I given you. All right, so pretty much let's just get right into it. Okay, so a racing car here in this example accelerates from rest to 96 kilometers per hour west. Okay, and they do this in 4.1 seconds. We've got to determine the average acceleration of this car. Okay, so like every kind of question in physics, we need to first establish what we know and then what we don't know. So what we know is that we have this car accelerating from rest to 96. So when you see from rest, first thing that should pop into your mind is we're starting at nothing. So we have an initial velocity here. We have an initial velocity of 0 kilometers per hour. Okay. And I know it's kilometers per hour because of the units over here for our final velocity. Okay, and our final velocity is 96 kilometers per hour. Now I know we've pretty much established that we measure using meters per second. Here it's okay if we use kilometers per hour per second. It still translates fine to acceleration, and I'll show you both using kilometers per hour per second and then how we can find meters per second, so we can have it meters per second squared, okay, for our acceleration. Anyway, okay, and then we've got our time interval, 4.1 seconds, and we're trying to determine, because we don't know the average velocity. We do not know what that average velocity is. Okay. We pretty much have everything else. We just have to now figure out and solve for that acceleration. So let's rewrite. First thing we should do, we should rewrite the equation. Just a good habit to get into. Because once you continually practice, you'll pretty much never forget it. And then now that we've got our equation, let's just tackle it. Let's just plug in these numbers. So we've got our average velocity equaling to our final velocity, which is 96, minus our starting velocity, which is 0. We're going to divide that by 4.1. And what we should get, easy peasy, we should get like 23.4 kilometers per hour per second. Okay. And then more specifically, this is to the west. And then we've got our answer all ready to go, nice and neat. Because remember, kilometers per hour per second still works out just fine, but it's not ideal. So let's now get the answer. We'll get the same answer, but this time our units are going to be meters per second squared. So let's erase all of this, and let's try to solve for that. So I'm just going to quick start out with here. I'm going to start out with, because we already know what our initial velocity is, that's still just 0. And we know our time here is going to be 4.1 seconds. Okay. Now we got to change, though, that final velocity. And to change that final velocity, let's see which color. I'll go pink. And to change that velocity from kilometers per hour to meters per second, we're simply just going to use dimensional analysis. So kilometers over hours. And remember, we're always trying to get the old units. We're trying to get rid of these guys and swap them for the new units. Okay? So we're going to put kilometers here at the bottom so they cancel out. And it's going to be 1. And then we're going to put the equivalent of meters on top, our little conversion factor here on top. So if in 1 kilometer, we have 1,000 meters. Okay. So then we know, or should know, then because we've got kilometers on the bottom and there's kilometers up there, that'll cancel out. And we're left with meters. Okay. And now the top is done. Now let's tackle hours. So we put 1 hour up here, and we're trying to go from hours to seconds. Okay, so we put seconds on the bottom. Now in 1 hour, we have 3,600 seconds. Okay, and we'll do the same thing. Hours will cancel out, and we're left with just seconds. So now what we should have is that our final velocity should be, okay, let's see, our final velocity should be 26.7 meters per second, and more specifically to the west. Okay, so here's our final velocity. So let's get this written over to the side. So final velocity here is equal to 26.7 meters per second to the west. We're going to get rid of all this other stuff over here. We're going to erase all this. Get rid of it. I do wish they had a bigger eraser. This does okay. I wish it was bigger. Okay. So let's now do what we normally do. Okay, we're still trying to find that average velocity because we don't know what that looks like yet. We're going to plop in our equation. Like we normally do, and then just solve. So we've got our average acceleration is equal to our new final velocity, which is 26.7 meters per second, minus our constant, or at least in this case, the 0 meters per second for initial. The time stays the same. Okay. Plop that into our calculator. And what we should get is that we should get 6.5 meters per second squared to the west. Okay. And boom, we've got our answers for check your understanding number 1. Okay, so that's how I find those two. Okay. All right, so let's now move on to check your understanding number 2. This one's pretty simple too. The only difference is that if you can tell just by looking, there's some things we got to rearrange in our equation. So let's write down what we know and what we don't know. So we know initial velocity is 23 meters per second to the north. Okay. And we know also that our average acceleration is 7.2 meters per second to the south. Okay. We also have a time interval, 2.5 seconds. Okay. But what we don't know is we don't know our final velocity, and we're trying to solve for our final velocity. So let's write out our acceleration equation. And we just gotta, move some things around. I just noticed I used the wrong font or the wrong marker color, but that's fine. You still get it. Okay. So just in true algebraic form, in order to get this guy all by himself, we're going to take our time here and we're going to move him over. So it's being divided, but we're going to do the opposite on the other side of the equation. So we're then going to have our acceleration, our average acceleration multiplied against or by the time interval. And we still have our final velocity minus our initial on the other side. And now what we got to do is that we've got to get this guy over here. And if we have to do the opposite of whatever operation is happening, we've got to do the opposite of this. So if it's being subtracted from the final, we're going to add it over here. So let's do that. So then we would have something that looks like this. We have final velocity is equal to our average acceleration times our time interval plus our initial velocity. Okay, so this is going to be our formula here. Okay, we got the final velocity all by itself, exactly where we need it, just in the form that we need it in. Okay. So let's just plug everything in now. Okay. I'll keep it blue. So final velocity is going to be equal to the 7.2 times our time interval, which is 2.5. We're going to keep that all together, plus our, in this case, 23. Okay. We should put that in our calculator. And once we get in our calculator, what we should get, oh, and I didn't write the answer down on my notes. Here, let me just get that for you real quick. It's basically the answer that I've already got written down below in the speaker notes. But we should get here. I almost forgot about something. Sorry, if you caught it, maybe you caught it before I did. Remember, so we're moving in the northern direction, but the brakes are being applied in the southern direction. So because that's happening, we got to make sure that we put a negative on our acceleration because it's going in the opposite direction that we're traveling. Okay, so because remember, we're dealing with vectors here, and vectors do depend upon direction. So if our positive direction is north, south is going to be negative, and this acceleration is in the south direction. So our 7.2 will be negative. So it will be negative 7.2 times our 2.5, and then plus the 23. And so what you should get is that you should get for your final velocity, you should get a positive 5.0 meters per second to the north. Now, if you would have gotten a negative, which that would kind of mean that you, or at least it would mean then that you are accelerating quicker than you are traveling, or you're you'd be accelerating in the opposite direction quicker than you would be heading in the direction that you're traveling, or at least your value for the acceleration. Anyway, it doesn't matter. We can talk more about that in class. Don't want to confuse you even more than you already are. So this is what you should get. You should get final velocity being 5.0 meters per second in the northern direction. Okay. All right. So now let's move on to, now this one you have all the answers for. If you have any questions, ask me. Let's move on to problem number 4 now. Okay. So a track runner starts from rest and reaches a velocity of 9.3 meters per second in the forward direction in 3.9 seconds. We have to determine the average acceleration. So as always, let's take a look at what we know and what we don't know. So what we know is that we're starting from rest. So our initial is 0 meters per second, while our final is 9.3 meters per second in the forward direction. And it's in a time interval of 3.9 seconds. But what we don't know, what we're solving for, is the average acceleration. Okay. So another kind of easy one. We're going to rewrite our formula here, because again, we just want to burn this in our brains. We do not want to forget this at all. Okay. Though you'll have it available to you at all times, even on tests and on quizzes, it's always going to be there for you. But you just don't want to forget how it's applied. And it's just so much better and so much easier to know that it's like, oh, acceleration and I've got initial velocity and final velocity and time. Oh, easy. I've got this. I could almost do it in my head, or at least you can set it up in your head. And then you just have to write it. Okay, so easy enough. We've got everything we need. So let's just plug it in. So we got 9.3 minus 0 over our time interval, which is 3.9. So what this turns into is 9.3 divided by 3.9. And what we should get for our acceleration, we should get 2.4 meters per second squared in the forward direction. Okay, and then we have our answer. Okay, so 2.4 meters per second squared in the forward direction. Easy enough. All right. Now this one's going to take a little bit more time. So, sorry, a lot of talking today. So again, just as we start with anything else, so we've got the Renault Espace is a production car that can go from rest to 2.6 meters per second, or 26.7 meters per second with an incredibly large average acceleration with a magnitude of 9.52 meters per second squared. Now we got to answer the following. How long does the espace, space, however you pronounce it, take to achieve its speed of 26.7 meters per second? Okay, so again, for the millionth time, let's write down what we know and what we don't know. Okay, so again, from rest, so 0 meters per second. Final velocity, 26.7 meters per second. This time we're given average acceleration, which is 9.52 meters per second squared. And what we're trying to look for, is, let's see what color. Oh yeah. Is we're trying to look for our time interval because we don't know our time interval. Oh no. We need to know it, man. So let's write our equation up here because we're going to have to move some things around. But as you'll see, it's kind of easy to know what to move because we are just experts at algebra. Okay. And we're going to put our time down here. Now, because we're experts at algebra, we know that we can easily just take this guy here and this guy here, and we can just swap them. Okay. We can just easily swap them. Just switch them out. Okay. We know we can do that because we are intelligent individuals. So let's just do that. So we should get this. Since we're trying to solve for delta t, we'll have our final velocity minus our initial velocity over average acceleration. Wow, you guys are so smart. You're so good. Wow, this should be a new Dora show. Okay, so delta t, let's plug in our values here. Vamonos, 26.7. Our initial is 0. And then over our acceleration, which is 9.52 meters per second squared. You know what to do. You put that in your calculator, and then what you should shoot out here is what you should get here. Ooh, where'd my notes go? Ah, there it is. You should get 2.80 seconds. Okay, so to go from rest to 26.7 meters per second, it takes this car 2.8 seconds in order to reach that velocity, to accelerate if it accelerates exactly at that constant magnitude. So now we've got the second question. So what is the speed in kilometers per hour? Wow, I'm so glad you asked. So it's asking for speed. So obviously, since it's asking for speed, that is not asking for the acceleration. We're not using acceleration. It's just asking for our top speed here, our speed of 26 meters per second squared. Okay, our velocity, our final velocity, in other words. So let's get rid of all this. And we're going to use that handy dandy dimensional analysis again. So we're going to do that 26.7 meters over seconds. And again, we've got to get rid of this guy and this guy. We've got to change them to our new units. So we're going to use those conversion factors if I can get the color right. Okay, that's close enough. So old units are going to go on the bottom. New units are going to go to the top. So we want kilometers per hour. So kilometers on top, meters on bottom. Kilometers will get 1. So how many meters are in a kilometer? Wow, you guys are so smart. It is 1,000. I totally hear you from the other side of your computer screen. Get rid of meters. We're good there. Top is fine. Now we got to change our seconds. So we put seconds up top. We put hours on the bottom. 1 hour specifically. And I know that there's 3,600 seconds in an hour. And I'll check. Let's see. Yeah, seconds cancels there. And I'm left with kilometers and I'm left with hours. All we got to do is plug it in. And what we should get is 96.1 kilometers per hour. And let's say this is in the forward direction. It's in the forward direction. Here is our new speed / new velocity. Okay, 96.1 kilometers per hour. So good on you if you got that already. So let's keep on moving. Okay, so now we're talking about sailfish. So the fastest of all fishes is the sailfish. If this fish accelerates at a rate of 14 kilometers per hour per second forward for 4.7 seconds from its initial velocity of 42 kilometers per hour forward, what is its final velocity? Okay, in both kilometers per hour and also meters per second. So we're going to first start out with the kilometers per hour, because we all know that that's just a bit easier to deal with right now, just because everything is in kilometers per hour. So let's take a look here. So we are first given acceleration. So our accelerate, and we can see by the units here. So acceleration, it's average acceleration. It's going to be 14 kilometers per hour per second. A whole lot of units there. Our time interval is 4.7 seconds. Initial velocity is 42 kilometers per hour forward. And we're trying to solve for the final velocity. Oops, I didn't do the color right. Our final velocity. We don't know that yet. So because we've already done this, I'm not going to do the algebraic, I'm not going to show you algebraically how to get the, how it is that I got the, or to solve, how I got it to solve for final velocity. But just remember, it's going to be final velocity is equal to our average acceleration times our time interval. Oop. And then plus our final, or our initial, our initial velocity. Okay. So we're just going to plug everything in because we're just that good. So 14 times our time interval, 4.7, and then plus our 42. Now notice though, everything's moving forward, so we don't put any negatives here with the 14. We're not accelerating in the opposite direction like the last one. Okay, we're all moving forward because we're trying to figure out what this final velocity is. Okay, so what we should get once we plug all this in the proper order, our final velocity in kilometers per hour should be 107.8 kilometers per hour in the forward direction. And then we have our answer. Good, so we got that. And again, we're going to use that handy dandy dimensional analysis again, because now we got to answer the second part. We got to figure it out what it is in meters per second. So it's going to be 107.8 kilometers per hour. Again, because we're trying to, wrong color. We're trying to get rid of these guys. So we're going to put kilometers below, and we're going to put meters above. 1 kilometer, and there's 1,000 meters in every kilometer. Okay, that cancels out, and we're left with just meters. And then we're going to do the same thing with hours. I'm going to put 1 hour on top, and then 3,600 seconds on the bottom, because I know that. This is gone, that's gone, this is left. So what my answer should be, after I plug this in, what I should get is I should get 29.9 meters per second forward. Again, this is for my final velocity. Okay, final. My little pen tip is starting to come loose. Uh-oh, hold on, sorry. Don't do that yet. Okay. And then I've got my answer for final velocity, both in kilometers per hour and also meters per second. Okay, almost there, guys. I think we got one more, two more. We got one more. Okay. So an arrow strikes a target in an archery tournament. The arrow undergoes an average acceleration of 1,370 meters per second squared west in 0.0312 seconds, and then it stops. Determine the velocity of the arrow when it hits the target. Okay. So what we should understand is what's implied here is that the velocity that they're asking for, that's what we don't know. That's our final velocity. Oop, don't change my color, please. Stop changing my color, please. That is going to be our final velocity. We don't know what that is yet. But what we do know, because either we've done archery before, or we've seen someone do it before, we know that an arrow doesn't begin flying. It's at rest. So our initial is going to be 0 meters per second. We're given the acceleration. On average, it's going to be 1,370 meters per second squared in the western direction. And we're also given our time interval. It happens in less than half a second. Okay, way less than half a second, in 0.0312 seconds. So we've got everything we need. All we have to do, because we are trying to solve for final velocity, again, just like the last one, we're just going to use that formula we've already used twice now. Okay. So we're going to multiply that the time interval with the average acceleration, and then we're going to add our initial velocity to this. Easy peasy. All we got to do, plug it in. So our average acceleration, 1,370 times our time interval, which is 0.0312, plus our 0, because remember, we're starting at rest. We plop that in to our calculator, and what we should get is that we should get this. We should get that the arrow is traveling at the point that or right before it hits the target. We can see that it was going 42 meters per second in the western direction. Its final velocity was 42.7 meters per second in the western direction. Okay. So I hope what you're seeing is that it's such a crucial thing to fill this out, to tell yourself what it is that you know, what it is that you don't know. I am telling you, it is incredibly easy to do this. It's just a habit you've got to get yourself into. It is just crazy easy, or at least it makes things easier, crazy easier once you write it all down. And also this, when you get in that habit of writing out equations, once you get in the habit of writing down formula, things just get so much better. Things get so much easier. I know it sucks, and I know we want to get through all this stuff, but once you get in this habit, it's a world of a difference. So, okay, thank you guys. Thank you for watching. If there's anything that you still don't understand, make sure you let me know. Get a hold of me on Remind. Get a hold of me on anything. Talk to me, and we can maybe figure it out. We can maybe see what it is that we're not understanding. Okay? So thank you again. I'll see you guys in the next video.